Let's talk about what to do with exponents when they're in rational expressions. Another name for that is fractions. Consider these concepts. With fractions, of course, you want to simplify them. People say, well, I canceled when I simplify them. Actually, what you did was divide by the number 1. That's what canceling is, dividing by 1. Well, I'll tell you what that means. Consider 2 over 2 is 1. 13 over 13 is 1. X to the 5th over x to the 5th is 1. And in fact, anything over itself is 1. As long as you have something in the top and in the bottom, you'll always be equivalent to the number 1.
Now what am I gonna do?
Well, in this problem, let's break up each of the expressions and see what they're equal to. And then we'll look for 1s. Doesn't x squared really equal 2x's multiplied? Y to the 7th is 7 of them. X to the 5th is 5 x's. And y to the 3rd is 3 y's. Now, when we simplify, we're really dividing by 1 in various forms. X over x is 1. There's another 1, x over x. So anytime you have something in the top and in the bottom multiplied, you can cancel it. As far as x's are concerned, we're going to be left with 3 of them in the bottom, and that's what I have. Now, as far as y's are concerned, I can cancel anything in the top with something in the bottom, as long as they're the same and they're multiplied. And that leaves me with y to the 4th. And that's your answer.
What happened?
Well, I'm going to give you a shortcut in this case, so that you don't have to write all those out. Couldn't you say that we took x to the 2nd, x to the 5th, subtracted, and put the answer where the largest one was? Always works. Y to the 7th and y to the 3rd, we subtracted and put the answer where the largest one was. It's a lot easier that way, isn't it? So, we have a rule for this, and it'll be our third rule, the third rule of exponents. To divide expressions with exponents, all you really have to do is subtract the exponents. And I always say, subtract the smallest from the largest and put the answer, the result, where the biggest one was. The biggest one always wins. Okay? For instance, 3 to the 9th divided by 3 to the 4th is 3 to the 5th. Now you can check that by multiplying backward, because 3 to the 5th times 3 to the 4th, it does work, doesn't it? So you don't have to memorize this rule, just always check it. X to the 12th divided by x to the 5th, we can subtract exponents and we get the answer. Now let's check it by multiplying. Doesn't x to the 7th times x to the 5th equal x to the 12th? Yes, it does. So it works. Well, let's use that rule when we do this problem. That's really a to the 1th and a to the 4th. So we're going to go 4 minus 1, largest minus smallest, and put the answer where the largest one, the 4, was. A to the 3rd. B to the 6th and b to the 5th. 6 minus 5 is 1.
What a maroon. What an ignorant.
Now come on, we don't write b to the 1th. We only write B. Okay, so don't be writing ones, you'll embarrass yourself. Now, with the 4 and the 6, you can't go 6 minus 4. You know why? Well, they're not exponents, so they don't follow rules of exponents. They follow the rules of normal numbers or coefficients. So we're going to cancel, we're going to divide 4 and 6 both by 2, and we'll have our answer. So remember, exponents follow exponent rules, coefficients or numbers follow the normal coefficient rules. Here's a tricky one. Looks easy, doesn't it? But I want you to take a look at it. We're going to have A, 2 B's, 5 A's on the bottom, and 3 B's on the bottom. Now if I cancel, every time I have something in the top with something in the bottom, it's certainly legal, because that's 1. And I'll have an A to the 4th, and where will that be? Well, it'll be in the bottom, won't it? And with the B's, I'll have a B, and where will he be? Got to keep an eye on him. He's in the bottom, because that's where the biggest one was.
Is that your final answer?
Well, if you write it the way it is right now, A to the 4th B, you're representing that A to the 4th and B are in the numerator, and they're not supposed to be in the numerator. But you're saying I ran out of stuff for the numerator. Well, we're going to have to create a numerator, and what do we have left? Nothing. Well, you're going to have to create a 1. So you have to have a top. Remember, if you don't have anything, put a 1. Got the idea? And that's the answer in this case.
Let's look at the replay.
We'll do that again. If I used my other shortcut, I went A to the 5 minus 1, put the answer where the largest one was. B to the 3 minus 2, put the answer where the largest one was. And then I said, uh-oh, can't go around here without a top. I'm going to have to put a 1. Very important. There it is.
Going so soon? I wouldn't hear of it. Why, my little party's just beginning.
Let's try something that involves all the rules. Remember the order of operations. We always have to do what's in parentheses first. Then we execute our exponents. I don't care whether we're covering exponents, we have to do what's in parentheses first.
And now, ladies and gentlemen, let's get ready to rumble!
So pay no attention to that 3 on the outside. Inside of parentheses, we're going to have a fraction. That's going to reduce normally. 6/9 dividing top and bottom by 3. I'm going to have 2/3. And that has nothing to do with exponents. That's just normal canceling. Now this is exponents, and I'm going to go 6 minus 2, and I'm going to have x to the 4th in the bottom. And this is going to be 7 minus 2, and I'm going to have z to the 5th in the top. Now I've done what's in parentheses.
Over? Did you say over? Nothing is over until we decide it is.
Now I've done what's in parentheses. I'm not finished. I have to do the exponents, and there is one.
I'm trying to think, but nothing happened.
I have to do that 3, and he has power. Look at the size of those parentheses. He has power over everybody. So I'm going to raise everybody to the 3rd power. Z to the 5th to the 3rd power, remember the second rule of multiplication of exponents, is z to the 15th. X to the 4th to the 3rd power, multiplying is x to the 12th. Now you're not going to use this rule for that 2 because he's not an exponent. You're just going to have to raise 2 to the 3rd power. 2 times 2 times 2 is 8. And 3 times 3 times 3, here again, doesn't follow the rules of exponents. because 3 isn't an exponent, it's a coefficient. And I'll get 27. And that's your answer. So always follow the order of operations. Now, they may bunch these together into one problem, something like this. But I want you to understand that it really is 3 little problems. And then I just do them separately. This one, 21 divided by 3 is 7. X to the third divided by x to the 1th is x to the 2th. And the y's cancel, so I get 7x squared. This one, 6 divided by 3 is 2. X to the second divided by x is x. And y to the 4th divided by y is y to the 3rd. So we end up with negative 2x y to the 3rd. And then finally, when everything cancels, what happens when everything cancels? Or think of it this way. Anything over itself, what does it equal? 1. Don't forget that 1.
Here is today's final Jeopardy answer.
Let's try one more. I want you to understand that this is going to become 3 little problems. Let's try it. In this part of it, the 2's cancel, and x to the third divided by x to the, remember, 1th is just x to the 2th. In the next one, 6 divided by 2 is 3, and x to the second divided by x is x, so we get a minus 3x. Now in this one, the x's cancel, and I can't do anything with the 3 and the 2, so I don't. It's not that hard, I just don't do anything that I'm not allowed to do. And I just write 3 over 2. Okay? That's about as tough as it gets. Make sure you don't put together unlike terms also. Okay? Go try the homework.